All right, welcome back to Daily Math Concepts. What we're looking at today is a reflection. But this time what we want to look at is a reflection in the line y equal x. So our mirror line today is y equal x, and here is it. This is the line y equal x. And so what we want to do is to figure out if we should reflect this object here through this mirror line, where will the image be? And then we want to look at some relationship between the points for the object and the points for the image. So let us see how we go. All right, if you're going to reflect across these slant lines, right? Basically, what you want to do is to find a way to get to the image. There are a number of ways that we could do it. I'm going to look on two ways now. One of the ways is that you could go across the diagonals. For example, I'm moving the point E. I'm going across the diagonal. As you can see, check out this diagonal here. Like going across a diamond shape to the mirror line, and it's 1. So it's going to fall 1 diamond shape on the other side of the mirror line right there. So my point will actually land there. If I'm moving the point D, let's look at D here. And I'm going across the diagonals. Look again, pay attention to this line. Here is a diagonal. That's 1, 2, 3. So it would have taken me, let's go again, 3, going across 3 diagonals to the mirror line. Then I'm going to continue on that straight line. 3 is going to fall all the way here. So that would have been where the image for the D is. And for the C point here, going across 2, look again, 1 diagonal, 2 diagonal, then it's going to fall 2 diagonal behind here. And we normally try to do this when we are actually reflecting across a slant line. So let me put back my labels. This would have been our E prime. This is the D prime, and this would have been the C prime. So what we want to do here is to recreate the shape. Recreating the shape, and we're looking at this. And when you really look at it, you're seeing that it was really reflected across the line y is equal to x. So if we should look at it without those lines on it, it looks like this, right? So when you reflect across the line, you're going to get this. So let us now just quickly look at some details, all right? So that's y equal x. So some details that we want to look at here is, let's look at, so this is my E prime, this is my D prime, and this is my C prime, right? Now, let's look at the coordinates. So this is the object here. And we're talking about C was -1, 3. D was actually 0, 6. And E was actually 3, 5. Now, when we reflect in the line y is equal to x, now if you listen to the sound of that y is equal to x, you would realize that C prime, D prime, and E prime, they would have come off a certain way. And we're going to quickly look at that. C prime becomes 3, -1. D prime becomes 6, 0. And E prime becomes 5 with a 3. If you take a close look to these two sets of points, you would realize that the X and the Y just switch. So if you don't like to count to the mirror line and then go behind it or to the other side, you definitely would need to remember that if I have the coordinate x, y, and it is reflected in the line where y is equal to x, the new coordinate would actually have the y value comes first, then the x value comes after. So there's a switching of the points. It's like an inverse, right? So the x becomes the y and the y becomes x. Take a look at this other reflection. So in this one, we want to look at reflecting an object in the line y is equal to negative x. You could see the line for y is equal to negative x. All right. So what we want to do is to employ the same strategy. We want to use the diagonals. So we're moving from, let us say we have C, 1, 2, 3.5 diagonal. We're expecting to go across a half, then 1, 2, 3, right there. Then for the F here, 1 diagonal, so it's going to go across 1 behind it. E, 1, 2.5, half, 1, 2 there. And D, 1, 2 diagonals, 3.5. So it's going to go a half, 1, 2, 3. There you go. And then, so basically you can employ that strategy when the line is slant to go across the diagonals to the mirror line and then count the equidistance in the other direction. So when you do that, you want to recreate the shape, right? So you want to recreate the shape easily. And here we go. So there is our reflection in the line y is equal to negative x, right? So that's our reflection in the y is equal to negative x line. Now, what we want to do is to quickly take a look at the points, right? We want to observe the points to see if there is any pattern that we could pick up, that we could use to help us in understanding what's the relationship between the points for the object and the points for the image, right? Now, let us write down the coordinates of the points that we have. So here's the object. So I have C, which was -8, 1. I have D, and D was -6 with a -1. B, C, D, E, and E was -4, -1. F, and that was -4 with 2. And so we're going to see when we reflect it in the line y is equal to negative x. So going across y is equal to negative x, then it would create some image. I call that I. So we're going to have C prime, and C prime becomes -1 meets 8. D prime becomes +1 meets 6. E prime becomes +1, +4. And F prime becomes -2 meets +4. What we want to do is to observe the points quickly. So y is equal to -x. If you take a quick look, you would have noticed that the points actually switch. So the x becomes the y becomes the x, and then the sign of all the numbers would have changed. For example, if I have x, y as my coordinate, when it's reflected in y equal to -x, then what we're going to have is the y comes at the front and the x goes behind. But the signs would have changed for both of them, right? So you'll end up with a negative y and a negative x, like the negative of what was. So we're seeing where -8, +1 becomes -1, +8. -6, -1 becomes +1, +6. So we switch x and y, and then we change the signs that are on the numbers. And that's a way in which you can easily reflect any object across y is equal to -x. See you next time. Bye-bye.